Welcome. My name is Øyvind Ingebrigtsen Øvergaard. I have my colleague Gard Rimestad here with me. We both work at Schibsted. Today we're going to show you how we have evolved our continuous delivery workflow for deploying applications to Kubernetes with Spinnaker over time. So let's start by giving you some context around Schibsted so that you can better understand our challenges. So Schibsted Media Group, as the name implies, is a group of organizations. There are around 100 different ones. We have online marketplaces, newspapers, different online news sources, as well as other miscellaneous sites, as well as some supporting organizations. There are over 1,000 software developers total across the different sites. And these different sites were initially more or less autonomous in terms of how they worked. And moving like this for years has led to similar problems being solved in different ways in different places. For example, some sites are running on-premise, some are running in the cloud, and some do kind of a combination of both. This also means that the different sites have different levels of maturity and tool sets with regards to how they do continuous delivery. So to drive convergence across the different organizations, a central product and technology organization was established around 2015 to try to find common ground across all the sites and leverage economies of scale to solve the important problems in one way for everyone.
Øyvind and I have been Øyvind and I am in the part of the central tech organization. Our mission is to promote continuous delivery and build infrastructure to support it. We work hard to make it easy getting into a flow that makes deployments so cheap that all master builds go out to production. It's an established fact that reducing the deltas on each deployment reduces the risk of bugs and lowers the lead time on fixing them, as the developers already have the change set fresh in mind. The base requirements for our solutions are: number one, it should be easy to bootstrap a new application. Maintaining an application should be as cheap as possible and require as little effort as possible. Central maintenance should be possible to do without involving all the users. For example, when upgrading a Kubernetes cluster, users should only be involved if the changes affect them or requires changes in their code. In order to do this, we must know their footprints for all our users. Øyvind will get back to this later. Transparency. It should be easy to see who deployed what and when. It should be easy to navigate from the outside in and also from the inside out. By outside in, we mean that from our continuous delivery tool, we should be able to look at an application and learn the footprint of the application, what resources are connected to this application. And by inside out, we mean that you can use kube control to look at objects and see what commits that made them and what pipeline execution that created them, and that you can browse to your pipelines and everything from kube control, looking at annotations. This is our golden path for deploying application. First, you put your code in Git. Then it's picked up by Travis and being built in the CI system. Artifacts are being uploaded to Artifactory. When the build is complete, Spinnaker integrates against Travis and finds the builds and also looks up which pipelines to trigger. It can be one or it can be many. Then Spinnaker deploys to Kubernetes through FIAAS, leveraging our FIAAS service that Øyvind will expand on a little bit later in the presentation. So many of you might not know what Spinnaker actually is. It's a sail that you put on the boat to increase the speed of the boat. In this context, we are talking about the tool Spinnaker. We have been running Spinnaker in production for 2 years now, and we're doing about 400 unique production deployments each week with it. At the heart of Spinnaker, you find the orchestration engine. called Orca. Each pipeline runs in an atomic way, so that there's only one truth for the state of one pipeline execution. Spinnaker integrates against many systems and builds a very powerful solution by combining all these solutions together and getting more strength than you would from each one of the individual system alone. Spinnaker has many kinds of stages. I'm going to mention a few that is relevant to this presentation. First off, you need your pipelines to be triggered. I mentioned CI builds could trigger a pipeline, but you can also trigger based on other pipelines, and you can trigger them manually and rerun them manually. There's also a lot of cloud operations. Spinnaker abstracts over the low-level cloud operations and gives stages for cloud operations like deploy, scale, destroy, and so on and so forth. There's also a stage called the webhook stage, which is built by Schibsted, which is a custom stage. We look at it as our get out of jail for free card. And you'll see how we've used this to extend Spinnaker to cover our needs with regards to Kubernetes in this presentation. Spinnaker can also trigger CI jobs. So you can, if you have integration tests, you can trigger a job on Travis or Jenkins or GitLab CI to run the tests after a deployment to make sure it meets your business requirements as well. And last, we have the manual judgment. If you need to decide manually if it's okay to proceed to production or not. Here you can see a pipeline execution in Spinnaker. This pipeline has been triggered by a Travis job. You can see that in the far left corner. It's a link to the Travis job that triggered this pipeline. And Spinnaker extracts all the artifacts that are listed below from this this CI job. So we can see all the artifacts that has been produced by the CI job. Spinnaker injects this into the context of the execution so we can use it later out in the pipeline. This pipeline consists of 4 stages. There's 3 deploy stages and 1 manual judgment. It deploys to dev first, then pre, then you have manual judgment, and then we deploy to production. Each of the deployment stages consists of 3 sub-stages, which make up dev deployment, pre, and pro deployment. The green stages are complete, and the blue one is in progress or in flight. You can press all the stages and look at what's going on and see the details about what's happening in each stage. And you can see that at the bottom for a Kubernetes Manifest upload. So we started off deploying into Kubernetes for real maybe 1 year ago. And we were using the first Spinnaker integration against Kubernetes, and we were very early adopters. And to us, it turned out to be very hard to manage. There's so many settings to tweak in this integration. This results in many unique pipelines and Kubernetes footprints. These pipelines had to be set up by pointing and clicking in the UI for every application. This made it very easy to make mistakes, even though you were knowing what you were doing. And there was no easy way to trace the different versions of the pipeline. So if a change you did in the pipeline configuration broke, it was not all that easy to revert it back to a working state. Here you can see a configuration stage for a replica set in all its glory. And it's basically just exposing the replica set schema into the UI. It's your turn.
Actually, it's your turn.
Oh, I have more. Another challenge we ran into with the first iteration of our Kubernetes pipelines was that users expect to be controlling more of their infrastructure footprint in the context of a deployment than what we were used to. Coming from AVS, the infrastructure was something we deployed our services on top of, and suddenly with Kubernetes, the infrastructure became a part of the deployment. Ingress, service, and config maps should be a part of the code and always deployed together with the application. We decided to build a custom stage in Spinnaker to do this. There already is the generic stage in Spinnaker, which I mentioned earlier, the webhook stage. So we simply created a service which runs inside the Kubernetes cluster, where Spinnaker can push the manifests for it to provision into the clusters. We call this our training wheels. Here is how it works for an ingress manifest. First, you store your manifest in Git as a YAML file. Then in the build, we upload this to Artifactory using a unique version. Spinnaker extracts the version and all the details about this manifest from the CI build. Spinnaker triggers the training wheel stage with a concrete version of the manifest uploaded in the CI build. Then the training wheels applies the raw manifest to Kubernetes. This solution was made to unblock our Kubernetes adoption. However, it felt wrong in several ways. One thing is that we lost control over who can deploy to which namespace. And also, we built a service to do the low-level operation that Spinnaker is supposed to do for us for free. At the same time as we did this, we also started off by creating pipelines as code to minimize the diversity that we experienced by allowing users to define and tweak so many settings in the deploy stage using the UI.
So, Gard has just talked about two of the ways that we have deployed applications and manifests to Kubernetes with. So both are using the raw Kubernetes API underneath. And Kubernetes really has an awesome API to manage infrastructure and applications. But in some ways, it's not that opinionated about how it wants you to do things. So at Finn, one of our marketplaces, we have developed a strongly opinionated abstraction layer to deliver applications continuously to Kubernetes. It is called FIAAS. Essentially, it works by abstracting a lot of the details away so that the users only need to care about the minimum of available configuration. This means that they can focus on what is important to them and not on managing infrastructure, effectively letting them move faster on what they really want to do, which is work on the services that make up the product and make that great. So the abstraction is really the FIAAS configuration format that you can see on the far left side of the slide, which defines defaults for almost all configuration settings. And we've tried to make the default values for each of the settings sane, so that, for instance, by default you get auto-scaling, you get a service object and an ingress, where the ingress host name is a function of the application name, unless you have explicitly overridden it with something else. And it's even possible to deploy an application with just one line of configuration if it fits all the defaults. So this configuration is typically stored as a YAML file in the application source repository. And during deployment, it's used as input to a custom component called the deploy daemon, which is responsible for hydrating the input configuration with cluster-specific information and transforming it to the Kubernetes objects that are necessary to deploy the application. So this is kind of illustrated in the middle of the screen, with the deploy daemon there in the middle, creating the Kubernetes objects in blue. And then the red box on the left is the relative size of the FIAAS configuration that's used as input. And the red box on the right is the resulting Kubernetes manifest, just to get an idea of the amount of configuration that's required. So deploying with this system among other things, has the benefit that deployments get more or less cluster agnostic, since cluster-specific configuration is injected in the transformation step. And this can make it easier to do cluster infrastructure maintenance, maybe deploy to multiple clusters, or do migrations between different clusters with minimal involvement for the end users. So if you, I'm just mentioning this quickly, but if you want more details on this system, you can look up the talk I did last year at KubeCon with one of my former colleagues, or reach out after the talk. We also have some of the code available on GitHub if you want to take a look at that. So we're using FIAAS to deploy, but I'm also mentioning it to sort of lay down some context because of the principles that it's built around. At its core, FIAAS is about managing flexibility versus being opinionated. And much like Kubernetes, Spinnaker provides a high level of flexibility in terms of how you structure your deployment pipelines and stages, as you saw previously on Gard's slide with all of the drop-downs and checkboxes and text fields. So we try to kind of evolve our approach to managing this flexibility over time. So after we've used this point-of-click mechanism to configure pipelines for a while, Spinnaker gained the ability to define pipelines as code. This is a feature that's sometimes called declarative pipelines. And this means that we can now have the pipeline definitions as source files that are part of the application's source repository. And that way we get version control for free, which is nice. And it also means that we can treat the pipeline configuration as an artifact of the CI build and use the specific version that's produced in the CI step to execute the actual pipeline in Spinnaker. This way we can do rollbacks using the previous version of the pipeline definition, even if we've changed and possibly broken the pipeline configuration in the current version. This is quite powerful. And additionally, the declarative pipelines can be expressed as templates that other pipeline configurations can build on top of. So what we've done is that we've used this feature to build a set of general templates that the teams can use to orchestrate deployments for applications to Kubernetes. So we're kind of applying the same concepts that FIAAS is built around to these templates, using an opinionated approach to managing flexibility and complexity, not only for deployment, but also for orchestration. So if you use one of these templates, you can get away with only minimal amount of configuration to set up a pipeline for your application, like illustrated in the middle here, where there's a flow of deploy stages, first to the dev environment, then to the pre or staging environment. And then we have a manual judgment step before deploying to production. So you can see an example of the configuration that's necessary to set this up above. You only specify the source template, the namespaces that we own. In this case, it's delivery. And we're also saying that we want manual judgment. So much like FIAAS, these centrally owned templates make it easier for us to make improvements on the deployment orchestration configuration and mechanism, and then roll these changes out to all the applications without having to change the actual configuration inside each application explicitly. So this, again, can be used to do different kinds of maintenance or do migrations. So let's look at how one of these deploy stages look inside. So to deploy to Kubernetes with FIAAS, we started out using the Spinnaker webhook stage that Gard mentioned. It essentially lets you define a kind of HTTP request template, which will be hydrated with information from the pipeline context at execution time. So we're using the webhook stage to post a request to a custom service named Mast. So Spinnaker is a sale, so Mast seemed like a suitable name for the integration point. And this request contains the application name, target namespace, Docker image reference, and the FIAAS configuration. Mast then creates a FIAAS application custom resource or third-party resource containing this information, depending on the Kubernetes version that we're targeting. Then there's the deploy daemon that I mentioned earlier. It's kind of designed after the operator pattern. So it's responsible for reading this FIAAS application configuration, transforming it to Kubernetes resources, and creating or updating those resources. It will also create a FIAAS application status resource, which describes the status of the deployment. Because we are only considering deployment successful if all of the pods that we are expecting are actually in the ready state. Then the webhook stage in Spinnaker will continue to poll mast for the status of the deployment. Mast will read the FIAAS application status resource and relay the status back to Spinnaker so that it can render a red box or a green box for the user to show whether the deployment was successful or not. So the webhook stage was built to be kind of an escape hatch for Spinnaker, where you can essentially bring your own stage as long as it is something that talks HTTP. So I'll let Gard get into how we've kind of evolved this process to be more Spinnaker native.
Yeah. So meanwhile, while we have been working with the FIAAS deployments, Spinnaker has been evolving the Kubernetes integration and implemented a shiny new one. Instead of shoehorning Kubernetes into Spinnaker terminology, they have created a new integration that embraces Kubernetes and brings the strengths and flexibility of Kubernetes into Spinnaker. The Spinnaker core team has listened to the community and rethinked how the Kubernetes integration should be done. Spinnaker Manifest-based Kubernetes deployments is the streamlined, fully integrated solution to managing manifests that we were missing. Conceptually, it's solving the same problem that we solved with our training wheels solution. The difference is that this is a native part of Spinnaker and lets us leverage the authorization mechanisms in Spinnaker to make sure that users can only deploy to the namespaces that they're entitled to. So our goal here is now to deprecate and remove the training wheels service, replacing it with the Spinnaker Manifest-based solution. So what's the key features of the Manifest-based Kubernetes integration in Spinnaker? It uses kube control to talk to Kubernetes, and you can specify you can have several kube control binaries installed on the machine, and you can use different versions and target different versions of Kubernetes having the right kube control version installed. This is important because the previous version were using a Java library, and it was a global library, so we were very unsure on how it will tackle different Kubernetes versions. Naming is only restricted to what Kubernetes supports, and Spinnaker-specific names and annotations are not forced on the manifest, but just added as annotations. It's easy to protect clusters, just like we do with the other cloud providers like AWS in Schibsted. And there's no coming new stages into Spinnaker that supports kind of hydration of manifests and stuff to that. So we will look into that and maybe include that in our creation of the FIAAS custom resources and such. Øyvind described earlier how Mast binds Spinnaker to FIAAS. Now with the version 2 Kubernetes integration, we've moved some of the responsibility away from Mast and into the Spinnaker native integration, because this gives us several things. First, as I mentioned, we get authorization, which is really important to us, protecting who can deploy to which namespaces so that we can't have one company destroying the clusters of other companies. Mast can now run with less privileges. It doesn't need to be able to create resources and apply manifests in all namespaces. It only needs to be able to read some data. So it's a lot more secure. Mast is more secure now. So now in Mast we generate and hydrate the FIAAS YAML file and creates the TPR or CRD manifest to deploy to Kubernetes. Then Spinnaker actually applies this manifest. And then mass status is being pulled to track the progress of the deployment that the FIAAS deploy daemon actually does. So, as I mentioned earlier, we hydrate the manifests in Spinnaker. And what we're doing is to inject CI data, commit data, and so on. In order to surface this to the end user, we built some customizations on top of the vanilla Spinnaker UI. We use the public NPM packages of Spinnaker and add our customizations on top of that. As Øyvind mentioned, we are a quite large and distributed organization, and one of our goals is to drive for convergence. How can we help each other promoting endorsed solutions internally? In the delivery team, which we are a part of, we have approached this by linking services together. In FIAAS, we provide paved roads to get Kubernetes deployments, secret handling using our internal secret management stuff, and also metrics using the centralized Prometheus setup. In Spinnaker, we have created a custom UI to make the FIAAS experience better and to expose the other tools we have by binding them together in a combined view. We believe that we will, on the right side here, you can see some details about this replica set. This is a screenshot from our Spinnaker setup. And we identify that it's a FIAAS application, and we show custom sections to the users. We have lifted information that we think is important to the end user. And here the user easily can see what commit that is actually running in production, get the link to the build, and also quality gate, code quality reports, metrics, and documentation. This is visibility from the outside in, so you can see kind of the footprint of your application. Another thing is that all these fields are added by having annotation in Kubernetes on the manifests. So when using kube control, you can see the same data. So we believe that we will get a lot out of building our own tight integration in the UI to make Spinnaker a natural place to start when debugging issues and trying to understand how an application works. And combining these things through annotations, we can direct the user in both directions to investigate the problem. There's been done work upstream to make it possible to extend the UI by just using annotations. And this is an example of that. So here, Nyancat is added to the UI just by adding a special key to the annotations and some HTML on the value. This can, of course, be used to more useful stuff like links to admin interfaces, specific dashboards, the front end of the service, or whatever the team or application owner finds useful.
So in terms of adoption on this system, we have quite good adoption of Spinnaker itself with around 400 production deploys a week. And FIAAS is also well proven as the deployment system of choice at one of our sites. But we're still in the early stages of adoption of this kind of integrated system with templated pipelines and integrations in Spinnaker and so on. So we have several teams and sites that are involved in the early stages of getting started. We have one site that has 75% of their services being deployed by FIAAS, but not using Spinnaker for orchestration. And we have one site that are running more or less all their services, kind of on an earlier generation of our pipelines as code templates, which use the first version of the Kubernetes integration in Spinnaker with training wheels. And we've used a lot of learnings from that process to improve the templates into what they look like now. So we're still working hard on getting more adoption. In terms of next steps for us, We want to continuously gather input from our early users to refine the abstraction that we're building, so that we make sure that we expose only the things that are necessary and abstract over the things that aren't. Also, like Gard just mentioned, we are doing work on integrating more of our tools with Spinnaker to make it easy to find the information you want when troubleshooting issues. So we could, for instance, do something like add a link to trigger our incident process, so you can start that when you see that something is wrong. And we're working on service-to-service integration in Spinnaker, so that we could, for instance, highlight deployments that might be affected by an active incident, for example, in the underlying Kubernetes cluster, or in the Docker registry, or something like that, with information regarding that incident, so you know that you might be experiencing issues. We also have kind of long-term plans for providing a single entry point for configuring continuous delivery for your application, so that you can configure build, pipelines, and deployment all in one place. And finally, we also have on our long-term roadmap to look into how we can provision databases and queues for applications automatically based on deploy configuration, rather than users having to set those up on the side, which is kind of what they have to do now. So to try to wrap up and provide some learnings, it's nothing revolutionary, but we've learned that it's important to continuously improve your workflow. Designing up front is hard. You'll get it wrong. So start working one way and continuously improve based on what works and what hurts. Another thing we've learned is that opinionated systems might be slower to develop, but can also pay off in easier maintenance and operability over time. And being opinionated about how you do things is especially important when you have a large number of services, because you can much easier make changes across all the services if they look pretty much as similar as possible from an operational perspective. All right. If there are any questions, you can feel free to ask, or you can reach out to us outside the room after the talk.